What's up, everybody? Okay, so no intro music because I'm just trying to get right to it. Um, I don't have like too much time right now, but hopefully I'll have some more time later today. So I'm really gonna try to bang out this style compiler. So I kind of forget. I worked on this a little over the weekend without actually recording anything. So I just want to go over like where we're at with styles. So basically, and this would be helpful for like um writing this compiler. And I say compiler loosely, like parser, whatever. So we have this style buffer that gets composed when you know when we do the layout. So basically, it's composed very similarly to the element buffer. It has the concept of like depth, and so on and so forth. Okay, so let's go look at style buffer, and then let's also have API open. I can't open it over here. Okay, there we go. All right, so when we create a box, every box has to have a style because every box is rendered technically. I mean, we could create a style, and let's just start with every box has to have a style. Let's start with that. So in our style buffer, right, we have something we have called begin style. What does this do? Okay, so begin style writes our the depth. So we expect a stud uint 16t representing the depth. Okay. Next we have like our individual style function, which when the style function actually gets called, I don't know why this that's weird. If I go right click, where even is it? I don't know. Maybe I'm being stupid. Either way, when style actually gets called, we call end style. So what does end style do? That's so weird. It's like going to the wrong spot. Whatever. I probably have to restart, but whatever. I'm just gonna be productive. So end style, we write end basically. So we have an end token. So once a style is done, we kind of expect another style, and then so on and so forth. Okay, so within this style, what happens? So we write something like, again, this is going to go to the wrong spot, but we sort of say by default. So there's sort of like, as we parse this, there's going to be something like, we're going to have like style state or like I don't know, we're going to have like some stack or I'm just going to say state. And state, every time we read depth, we're going to reset state to normal. Read depth, reset state to normal. So calling normal here doesn't actually like do anything useful. It's literally just for like aesthetics. So the idea is that if you want to just like write the style of something without like, caring too much about well, actually we do need normal here because of this function, but if you just want to write a style and you don't want to care about like normal versus hover versus active, you can just write something like dot style and then dot background color border width, right? I mean, obviously we need like a value there. So this by default does normal, right? So, because when we read depth, we reset the state to normal. Okay. Anytime we come across this style operation state, and the operation could just be like, maybe it should be like set state, just to be a little bit more clear. So let's say we encounter something like set state. Then we want to read a I think what type would this be? Do we actually specify? It's a, okay, it's a UNAT. Okay. UNAT. State. Okay. So we may or may not have this, but if we do have this, this toggles like, you know, anytime we encounter a set state operation, we change state to the following value. Okay. So we know that is going to happen. So then literally what's next? Okay. It's actually very simple. You write a field and then a value. So field value type. Okay. And then this goes on, and then you might have, you know, update another state. You would have this set state here. And you just have like fields of values, fields of values, fields of values. Once you hit end, you're done. Okay. Then you have the depth, so on and so forth. So this is what the buffer looks like. Now, what do we emit? What does this actually get us? Okay. So, and I haven't written this yet, so I'm sort of like unsure exactly how this is going to work. But or I have an idea of how it's going to work. It's just, will it work is the question. Because like I actually really want to start, like, you know what I mean? Like I want to actually start rendering stuff to the screen, because I feel like this is boring, just like listening to people like talk about things that you are going to do. And it's like, oh, theoretically, like he's got all this like trust once, you know what I mean? Like trust there will be stuff on the screen. But you know, this is version 3. Like I've already had stuff on the screen, so I'm not so concerned with like, can I actually like render stuff? Like I already have like the rendering pipeline and everything set up. Obviously that is probably gonna have to change, or I'm gonna want to change that in version 3, but I'm not gonna like, that's not the focus of this library. Like ideally this library doesn't even, you know, we can provide a renderer for this library, but you could also render this library with whatever you want. That's sort of the idea. Like we'll provide like a tie engine like wrapper for using it with this like game engine or render. Whatever. It's beside the point. The point is we have something like as we traverse this style, we should have like struct like style. And what is that? So that can be like, that's every single thing that we can possibly set. I think that's how it should be. Because everything technically has a value. So we can have like color background, color, border, color text, color, what other I mean, I might separate text stuff down here. So like float, border width, float, border radius. Well, we could actually border rate. I mean, this is gonna be interesting. What I've been doing, and I'm just gonna keep doing this, is sort of like shape arg, and then shape. Oh, I actually include that. It's not gonna find it. Oh, okay, it did. Okay, rect, rounded rect, circle. So like, if your shape is, for instance, like if your shape is a rounded rect, your shape arg would be like border radius. If your shape is a circle, the arg might be radius. If your shape is a rect, you know, sort of a useless thing. So like, it sort of is just like a wildcard variable instead of having like border radius, and then like when we actually go to render, like, you know, conditionally like passing the shape, because like if we want to do a rounded rect, that's a different like sign distance function in the shader than a rect, which I think that makes the most sense. Um, okay. Anyways, continuing. Okay, so I actually have like wait, we don't actually include this, right? Oh. Well, okay. Shoot. Where? Okay. Oh, okay. We store it all in like a map for. It's kind of annoying, but I'm just gonna do something like. I'm gonna change this because we can do something with like, you know, this will be fine. We're gonna change this and then we're gonna have to change the shader, but we're not doing anything like, so like basically, okay, so background color, border width, border visible, float alpha, like just overall alpha, I guess. Custom stuff we're gonna skip. Shape arg. We're gonna skip clip info. Basically that says like if you are what does that say? That basically says like if you are if you are some element inside some larger element, it's like overflow in CSS, for instance. That's the best way to explain it. Like if your thing extends outside the bounds of your parent, or like, you know, whatever index you pass in the element with a given index, like do you do you get clipped by this element basically, or like which element do you get clipped by? I'm just not sure of the type of that right now, and we may want to handle that differently. But okay. So text style is gonna be, Jesus Christ, what in the hell was I thinking? Okay, whatever. I don't even know what this is. And we're gonna take out align too. We're just gonna do font ID, font size. Oh. See, this is interesting. We had this idea of themes. But you know what? I'm not going to do this. Okay. I had, okay, so this color ID, you might be like, James, what the hell is this color ID? Well, I'll tell you. Basically I was like uploading like a buffer of like theme colors to basically I was uploading a buffer of theme colors to the GPU, so that all I needed to do was actually just pass an index, and then it would read the color from the index and render it. Now, what I perceived was the benefit of that was twofold. So I could use the same IDs and then just swap all the colors. I could just change a theme by uploading a new buffer, right? That's easy. Now, if I needed to change the style of something, like let's say I have like a box or whatever, and it's like red, and then I wanted to basically it's like a way to like standardize your theme and force people to use themes. Now, the downside of that is like there's plenty of cases where you want to like test something out by doing like an inline style. And so that's what all this like use custom color, set custom color thing is. The issue is like that memory is already being like, you can't conditionally send buffers of like arbitrary sizes to the GPU. Like I'm not gonna do like real time like byte buffer parsing in a fragment shader. Like, right, that would be crazy, right? I think that's crazy. So like if we end up having to, if we want to allow for inline styling, which I think we should, then the style buffer is just going to be bigger again, I kind of think like when I started this project, it was sort of like, let's get something quick and easy to like theme. Like I just want to make a button. I don't care what color it is, right? I'm gonna set the color, forget about it. In this case, it's like, yeah, you could still write a theme with the original idea of like, you know, we have like a static style buffer that like never updates or like very rarely updates, and then this is like a dynamic one. But and we could even say like, I mean, there's ways to do this. I can think of a number of ways to like sort of like optimize for like different scenarios. So like I'm just gonna say like we're just gonna use text color, font ID, font size. That's just what we're gonna do for now. All right, so all these have to have default values. So let's do like RGB 000, and then border colors RGB 255 0 10, or like 100 200 0, like kind of like make like a red theme. Let's make the border width 2f. Let's make the border visible. Let's make alpha 1 for sure. Let's say the shape is a rect. Let's say the shape arg is just 0.f. Doesn't matter. Text color can be RGB. Let's just make it red 255 0 0. Font ID. I think font IDs start at 0. Font size can be 13. Okay, so this is like something that will like make something visible. Okay, so auto compile styles. Oh, we'll just do it like this, and then we'll pass a style context CTX. Okay, and then these can be refs. And then it's just like, again, this is sort of like a, okay, up to somebody else. Like we don't care how this stuff is stored. Which is sort of, I mean, I'll tell you the downside to this that sort of like breaks my brain a little bit is that this is useful outside of style context. I guess this stuff is too. Actually, I take that back. I think we really only, yeah, I take it back. Okay, so let's do this. Let's start writing code and see what happens. How do we set up the constraint solver loop? CTX.style buffer. Let's just call this R. Or reader, and then this has to be inline, obviously. Header only, baby, come on. All right. This way we can track the element stuff. We probably see we do want this like std vector style stack. And this, because this only, well, I'll take that as a ref too. This is, okay, here's the thing. This is not useful outside of this. All of these things should probably be members of like context or UI or whatever we end up, UI context, I think it's called. This, not so much. But we also want this to be persistent and stick around. We don't want to like have to, you know, allocate memory and whatnot. So, like, you know, we want this to be persisted somewhere, so we'll probably persist it somewhere else because we're not going to, well, maybe we do have it like this, and then we have like style context as a member of UI, and then like you know, if we do something like style context buffer style buffer, std vector styles, std text styles, style buffer, styles. I really want to get better at typing. Like, I'm not trying to be like using like autocomplete for everything. And then so we could do like stack.reserve. I don't know, but then it's sort of like, and we could say like std size t stack size equals 128. Make that const. I actually don't hate that. I actually am not upset about that. Let's do that for now. All right, we got about 20 minutes left. I kind of like these shorter ones. Like, I mean, if I have 2 hours to like lock in, like I really will. It's just that like it's not always that. Like, I also have to like apply for jobs, and I also have to like I have like some commissions in Blender that I'm working on. Like, you know what I mean? I got this doctor's appointment. I got like, you know, eventually I'm gonna have to go like pick up my car from the deal. Like, you know what I mean? Like I got a bunch of other annoying shit going on that is just like, do I wish I could just sit inside and code all day? Like, yeah, it's, at some points in the day, sure. And the only reason I don't have more time is because I was watching Jubilee earlier. I was rage baiting myself into getting hyped to like do this. Is that a fly? But if there's a bee in here, I'm gonna freak out. Let's say 15 more minutes. Okay. So because styles don't need to like solve anything, we'll just like we only need to do this once. Okay, so first let's just pull this up so we can read this, because this is what I'm reading, by the way. Can I not? Okay, yeah. I like C-line, it's just like sometimes like, are you on crack? Like what? Like I can't double click and open it in the currently selected window. It's just like some days I'm just like earlier I was just like recording in FL Studio. I'm just like, honestly, like I would take the time to write a DAW, because there's just not like, you know what I mean? Like all these DAWs are like old, and all these new DAWs like look ugly and stupid and don't like, you know what I mean? It's just like I've never written anything of that scale, but it's just like, why not? You know what I mean? I feel like I can do it better, and honestly, that's why I'm writing this, because I feel like I can do it better. And it's like, it's an ego thing. It's an ego thing for sure. Will I actually be able to do it better? Like, this is not gonna be better than like, I mean, it's gonna be different. You know what I mean? Like, everybody's special. Everybody gets a trophy. You know what I'm saying? This is I'm banking on sort of like a socialist approach to like software. I'm playing. I'm just, I mean, I don't know anything. All right. Style context. What am I doing? Okay, we're gonna write this compiler real quick. Okay. All right. So what does the stack represent? Well, the stack represents our current style. So, you know, because this is cascading, like we read things, we edit the current style, and then yeah. So again, we'll see what happens here. While reader is done, element type. So the first thing that we read is a std uint16t. Oh, we actually don't need lm type because we know it's a style. Okay, good thing we already had this logic. A younger version of me would spend all of his time right now trying to like generalize this all into like some shared function that you pass some like lambda to inside the, you know what I mean? Like, it's just not that deep. You know what I mean? Like, just copy and paste the code. You know what I mean? Pirate software way. You know, like I'm not coding Jesus. I'm not gonna like, you know, I don't know. The chosen one. I forgot to say that. The chosen one. The biggest choice. All right. Context stack and place back out index. Out index is 0. What? Oh, because the stack is. All right. Let's just say ctx.stack. I don't think we actually need an out index. And then we're always just like in place back ctx.stack.back. So what we should be doing, so we're copying what was already on top into the new thing. So we're pushing the default style onto the stack. Then when we read an element, we're pushing another style onto the stack that is a copy of the previous style. I don't think we actually need any of that. Okay. All right, so we're done with that. Actually, I'm just gonna get rid of it. I'm assuming this works. I'm not even gonna think about it right now because it is. Again, I mean, if you watch my other videos, like, you know, I'm like sort of I'm not anti-stack. I just get confused. It's sort of like, it's like I get confused by the plan that I came up with. It's nonsensical, really. All right. My voice is like so shot for some reason. Like, was I screaming all morning? Yes. All right, so context stack dot in place back, context stack back. Okay. Next, we say I guess we say something like this: auto op equals reader dot read. Oh, wait, hold on. We need to think about state, but let's not think about state. Style op. Okay. Yeah, include it. Okay, we're gonna have to work out this like dependency tree later. Okay, op equals while op is not equal to style.n, and then we'll read it again. Okay. Switch op. Okay. Nope. I like this one. Generate just in case statements. Yay. Inherit. Let's not do anything. I also like my spaces around break. Yay. Yeah. Yay. The chosen one. All right, this one. Whatever. It's so stupid because it's like, oh, this is never gonna happen, and then like I take this out, and it's like, you know, Clang Tidy is freaking out, and obviously Clang Tidy should freak out. I forget how I handled this last time. Whatever. Cause if you say something is normal, all right, let's not think about state right now. Let's you know, if we're setting background color, we say cur style dot background color equals reader read color. Okay. Text color, border width, border color. Okay, so I mean, this is probably gonna have to change, but so like this is, we change it. So this is pretty much how this is gonna work. The issue is like how, like, what does state mean here? Like what I'm struggling with is like, so if we say like inherit from a static style from another buffer, or beginning of okay, so we could do something like that. Or copy a, well, yeah, let's okay. Let's not think about inheritance right now, or like classes in CSS. That's sort of like what I'm trying to emulate. Okay, so if we say something like set state, so this is the default style, right? This is like default style for all states. If I come along and say on click oh man, okay. This is a little confusing to me. Excuse me. All right. Default style for all states. To do, figure out how to handle states. Okay, I gotta stop. I gotta go. I have a doctor's appointment. This was not as long as I had even hoped, but I'm gonna post it anyways. We're really trying to figure out this cascading style sort of situation. I'm really trying. I'm trying to have my cake and eat it too. I'm really trying to like do everything. I'm really trying to handle all cases and still have it be like pretty performant. It's just that, like, you know, this style solver, it's like, oh well, this is gonna take up a lot of memory to do, and then it's like, well, we don't want to like go like this with like, you know what I mean? You want to have all your memory like pre-allocated at the beginning of the program. So like, if it takes up a lot of memory at once, that memory needs to always be assigned to this style buffer. I don't know. We'll see how it goes, but I'm gonna do another one later this afternoon when I get back in like hour and a half. Peace.